A car isn't destroyed when it goes into these machines. It's erased, 10,000 parts, engineered to survive decades, reduced to a block of metal smaller than a dishwasher in under 60 seconds. And the scariest part isn't the power, it's the silence. No straining, no struggle, just steel disappearing, calm and unhurried, like it never mattered at all. Today, we're looking at 12 machines built to crush, shred, and erase, and exactly how they do it. Number 12, high-torque twin-shaft shredder. The fact that it spins slowly is a deliberate choice, not a weakness. Two shafts rotate in opposite directions, tearing material from both sides at low speed with massive torque. High-speed shredders throw debris everywhere as a side effect of their own velocity, but this one doesn't because it doesn't need to rush. Once metal touches those shafts, physics finishes the job regardless of how fast the rotors turn, and slow simply means the machine takes all the time it needs without ever running out of force before the material gives way. Number 11, hammer mill fragmentizer. This is the end of the line for most shredded material. Cars, appliances, and scrap metal of every kind enter intact or in pieces. And fist-sized fragments exit, uniform and graded and sorted by density before they even leave the conveyor. The hammer mill has one output specification, and it hits that target every time, no matter what the input looked like going in. That consistency is the reason shredded steel functions as a tradable commodity on the other side of the world, bought and sold by the ton without anyone needing to inspect the pile first. Chaos goes in and a finished product comes out. Number 10, Bronner RR5. 200 tons of force sounds like brute mass, but the Bronner applies it with something closer to intelligence. It reads the vehicle's frame geometry, locates the structurally weakest points, and applies pressure exactly there, in sequence, rather than fighting the car's strength head-on. It exploits its weaknesses the same way a skilled hand finds the seam in something that looks solid, which is how it produces tighter bales and faster cycles, spending no energy on the parts of the car that were never going to resist anyway. Number 9, EZ Crusher. 10-inch hydraulic cylinders do the work here, and it makes no difference whether the engine is still inside. Full cars enter as is, with no draining and no disassembly, finishing a complete cycle in about a minute. The design is brutally simple, with fewer parts to fail and more cars processed per shift, and in yards where more sophisticated machines sit idle, waiting on spare parts, this one keeps running year after year because simplicity is its own kind of reliability. In scrap economics, uptime is the only number that actually decides who stays profitable. Number 8, Wendt 130 Heavy Shredder. A shredder builder in Tonawanda, New York spent 45 years refining the craft before they built this one. The Wendt 130 Heavy runs on motors rated up to 10,000 horsepower, while the famous LYNXS in Wales, often called the world's largest operational shredder, runs on 9,200. The Wendt's top configuration quietly beats it without anything close to the same global reputation. The frame is also 50% heavier than comparable machines, because at these force levels the shredder itself has to survive what it's doing to everything else. The most powerful shredder motor configuration in the world isn't in Wales. It's in America, and most people have never heard of it. Number 7, Big Mac Auto Crusher. This machine doesn't roar, and it doesn't need to. A full-size sedan rolls onto the platform, and a hydraulic plate begins its slow descent with hundreds of tons of pressure behind it. Steel folds like wet cardboard, and glass becomes dust, so that in under 60 seconds, a vehicle that costs $30,000 is a flat slab ready for transport. At no point does the machine speed up or strain to finish the job. The terror isn't the speed, it's the quiet, and how completely it wins every single time without making a sound. Number 6, Power Hand VRS. This isn't really a crusher so much as a surgeon with a temper precision. Hydraulic grapples and shears tear end-of-life vehicles apart before the shredder ever sees them, taking the doors first, then the engine block, then the frame, with each step deliberate rather than brute force. Yards that adopt it restructure their entire workflow around it, clearing inventory faster while keeping workers farther from the danger zone. That last part matters more than any specification on the datasheet. Vehicle dismantling has historically been one of the most injury-dense jobs in industrial processing: pressurized fluids, unstable frames, shattered glass under load. The power hand does not eliminate those hazards, it relocates them. The operator sits behind a cab, working controls, while the machine absorbs whatever the car decides to do when it comes apart. What looks like efficiency on a production chart is quietly also a safety argument, and in facilities running 3 shifts a day. The difference between a worker near the metal and a worker 30 feet from it compounds across every single hour the machine runs. The future of vehicle destruction isn't simply bigger machines. It's removing the human hand from the part of the process where things go wrong. Number 5, Tonashark 430 DT. Watching it run is genuinely confusing because the rotors turn slowly and almost lazily, with no roar and no visible struggle, nothing that looks capable of what it's about to do. The reason is straightforward. High rotational speed destroys blades faster than it destroys cars, so the designers chose massive torque over velocity, building a machine that runs at a fraction of normal RPM and simply outlasts competitors in total working hours. Nothing has resisted it for more than 90 seconds. The danger hides in how effortless it looks, because low speed here still means total destruction every single time. Number 4. VB950DK Red Giant. The name turns out to be engineering fact rather than marketing. Workers nearby feel vibrations in their chest before they hear anything recognizable as sound. Low-frequency mechanical waves that bypass the ear entirely and register directly in bone, which is the physics of force at this scale rather than a figure of speech. But the vibration isn't actually the point. The density of what comes out the other side is, since every cycle produces maximum mass per cubic meter, worth more per truck and per mile of ocean freight than the same mass from a weaker crusher. Number 3. Lindner Urico 95DK. Every shredder has a preferred diet, and feeding it the wrong material means a jam, a stopped shift, and money burning while operators dig debris out of the rotor by hand. The Lindner Urico was built to eliminate that problem entirely. Dual counter-rotating shafts accept chaotic, mixed input without complaining, taking cars exactly as they arrive. Tires still on, seats still bolted in, oil still in the engine. Reliability in chaos is harder to engineer than raw power, and the Urico solved it. The safety protocols around it are strict, not because it's unreliable, but because it is completely, unconditionally reliable. It only consumes. Number 2. Overbuilt high-speed crusher. This machine changed where industrial destruction is allowed to happen in the first place. Truck-mounted and operated by a single person, it brings full hydraulic crushing force to an impound lot, a highway median, or a farm property instead of waiting for the car to come to it. But when industrial-grade force enters spaces never designed to contain it, the safety margins that fixed facilities spend millions of dollars building simply don't exist out there. The machine performs identically, whether it's inside a purpose-built plant or parked in an open field. The field does not. Number 1. LYNXS Shredder. Newport, Wales. This is the largest operational shredder in the world. And it's still running right now, in Newport, Wales, the same way it has since 2006. 40 tons of motor, 11,000 volts, 450 cars an hour. Those are the numbers everyone quotes. Nobody mentions how it actually works. The operator never touches the car. A conveyor feeds the chute 6 meters wide, and the sedan drops through without scraping the sides. The rotor turns at 25 RPM, slow enough to count, fast enough that nothing entering. Whole exits whole. One moment the vehicle is there. The next, it isn't. No stages, no warning. In 2008, a technician stepped past the line during a scheduled stop. The motor was off. The residual torque wasn't. 1/4 turn on stored energy alone was enough to rewrite the safety rules. The perimeter is now 20 meters, 40 million vehicles. 3 motor rebuilds. The same original frame, still standing under all of it, and right now, the next car is already on the conveyor. 12 machines. 12 different ways to make something disappear. But here's the part that should actually stay with you. These machines don't hate what they destroy, they don't fear it, they don't even notice it. They just apply physics, and physics never hesitates. So next time you drive past a scrapyard, look again. Somewhere behind that fence, a car is being unmade right now, in complete silence, by a machine that will never once look back at you. And tomorrow, it'll do it again.